Welcome to the manufacturing team's final presentation. As some of you may know, our team, consisting of Kevin GARCIA, ROSHKOVSKIY, and myself, TREVOR THRIFT, were paired with Lockheed Martin's manufacturing engineer, Joe Block, and the Advanced Manufacturing Laboratories to explore the capabilities of the EOS M290 as a viable direct metal laser sintering machine utilizing an innovative material, aluminum 6061. Additionally, we had a parallel goal to develop the best ways to apply the additive manufacturing methods to our design innovation process. Now, it's widely known the M290 is a very capable direct metal laser sintering machine, but some of our audience may not know that this process, known in industry as the DMLS, utilizes the powerful 400-watt laser guided by design geometries to weld powdered material onto a build platform. More on that later. Now, while many different materials are available and have been well established, aluminum 6061 has yet to been widely explored and adopted as a reliably printable material. But Lockheed Martin chose a material manufacturer, Elementum 3D, located right here in Erie, Colorado. And with their 6061, we set out to explore the capabilities of the machine building parts with a goal of determining the part production viability. Additionally, we sought out to develop a set of operator guidelines for the processes and procedures in which operators interact with the machine, understand the hazards of the machine and that material that we use, while also working to develop a preliminary checklist, one that designers could use as a reference when designing parts to be built on the machine. But due to our global events, our research was cut short, and we were unable to complete the development of much of what we sought out to accomplish. Nevertheless, we learned much about the industry and where it's going, the potential of this machine, and the viability of this product in production. But I will hand off to my teammate Kevin to tell you a bit more about the process, our final designs, and some of the parts we were able to complete. Thanks so much.
As we gain more experience using the M290 to make prototypes, we were able to pick up experience on design considerations for future parts. Picture here is a good example where the yellow highlight points out an area with significant overhang that would require a support structure to be designed into it. There are other things for this part too, like adding extra material to take into consideration for post-processing. Now this can come in two forms. The first one is adding a little bit of extra height to the part where it joins the build plate so that we can take into consideration the material that's going to be lost when it's getting cut off the build plate. The other one is right below that yellow highlight, that ring right there would be a mating surface, and that requires a little extra material added to it as well, because it's going to have to be machined down to get the desired surface. Another design consideration is shown here, and this is what happens to a part when you have multiple geometries coming together in the same layer. This is a behavior of the aluminum powder in that it pulls together and shrinks when you have multiple pieces joining, and it leaves those impressions lines on the build. This doesn't affect the part's strength overall, but it's not an attractive finish for what would be a space-ready part. Here we have three parts that were part of one of the two designs that were being considered for the brackets. On the left is the part where the rockets would have mounted, and you can see in the top corner, it has squares taking up that corner, and that was an attempt to limit the amount of support material that was going to be needed to be incorporated for this design, and those little squares right there eliminated the need for supports in that area. The middle picture was part of the mounting plate assembly, and it was utilizing complex gyroid lattices as part of the design, and you could see two different test builds right there to see how it would come out. That right picture is a traditionally machined valve plate, and that was going to attach to those pictures in the middle right there. The final design was unfortunately not able to be completely done with the M290 in traditional manufacturing due to some global events, but we utilized polymer printers to prepare displays, and if you look at the picture on the right, you can also see a representation of some of the complex support structures that were needed for parts that were going to be additively manufactured on the M290. That right there was achieved with the help of Joe, the engineer from Lockheed, and he was a super valuable resource for this part. Here's a small demonstration of the additive manufacturing aspect of our project in action. Here you can see the lasers tracing out the next layer of the part as a new layer of powder was just added by the recoating blade. And here is a clip of the traditionally manufacturing side of the project, and it's the valve plate shown earlier being milled into existence.